Now we have to study very important property, percentage GMM at the rate of n initial, percentage of GMM at the rate of n dist. How will we find out? First of all, let me tell you about their equations. Percentage GMM at the rate of n initial, its value can be found out by using GMB at the rate of n initial divided by GMM. This is a GMM at different PB. And 200. Similarly, this percentage GMM at the rate of n design, its value can be found out when we will use this equation GMB at the rate of n design divided by GMM at PB different. And 200. So these are the two equations which we will use for the determination. Now this value GMB n initial we have already determined. This value which we have already determined, all these values are determined already. Now I will tabulate their values. First of all, this PB, different PB. You know we have 4.1, we have 4.6, we have 5.1 and 5.6 percentages. PV percentage, let me, for your understanding, I can write down this value. With each of these quant, we have calculated the value of GMB at initial. We have calculated the value of GMB at n design for each binder content. Let me write down these two values, then I will explain it further. 2.538. This is the value calculated when the binder content is this one. 2.364. 2.365. 2.369. These are the value which we have determined already. Now for this GM, let me write down its value 2.536. 536. This is the value of GMB calculated at the design level of compaction. 2.556. 2.571. 2.575. Similarly, this value of GMM, theoretical maximum specific gravity, and each binder content we have determined its value. And this value is being tabulated over here, 2.690. This value will go on reducing with the increase of the binder content. 2.671. 2.650. And 2.630. Clear it? All this value from our previous calculation. But what is new over here? We will put the value of GMM in this equation. We will put the value of GMB initial in this equation. We will get a percentage GMM. Actually, it is the representation of the compaction. What I say? It is the representation of compaction at the initial number of gyration. So now I will have to find out percentage Gmm at the rate of n initial. As I have already told you, just for your understanding, this value will be placed at this point. Clear? Next, this value will be placed at this point. This value at this and this value at this. As I will go on putting this value, whatever the value of Gmm at n initial I am going to get, this I will just tabulate over here. 87.6% from this value, 88.5%, 89.2%, and then 90%. Similarly, we have to find out this value. What will we do? Now, this value will be placed at this point, and this Gmm already you know this one. At the rate of n design. This is actually showing how much is the compaction at 100 number of gyration. Because our design gyration is 100. So that's why we will study this value now. And this value, if these two values are put in this equation, what we are getting 94.3%. This is the value for this one. 95.6%. This is the value for this point. Next, 96.7%. This is the value coming when these two values are put. And at the last, 97.9% when these values are put in this equation. So this is very, very important to know these values, because when we have to draw the graph in my coming lectures, there we will show you how we are going to correlate with the amount of the binder content. Up to this one, this is the calculation, determination of percentage Gmm at n initial number of gyration, percentage of Gmm at design number of gyration. So please, the data is given to you over here, through which I have carried out whatever the value I have written in the last two rows. Better if you will also practice by your own hand for your accuracy. Thank you for seeing this.